Oh, great then. So last week we have started with our new lesson, addition of vectors, and we only took definition of addition of vectors. This week we have finished our lesson, so let us make a quick overall for the things that we have learned. We said that any vector whose magnitude is equal to the chosen unit is called a unit vector. So in another word, we are trying to say that a vector is any line that has a direction. And also we said that two vectors are said to be equal if they have the same direction, the same sense, and the same magnitude. So we say that vector AB equals to vector CD. Those two vectors could be parallel, as you can see, or they could be on the same line here, as you can see. I'm sorry. A vector could be represented using two letters, or it could be represented using one letter, U. Okay, so it's either vector U or vector AB. Both of them you can represent a vector by. And also we have explained already what's the meaning of opposite vectors, and we said that opposite vectors are vectors that have the same direction, the same magnitude, but with opposite senses. So vector AB equals minus CD. What's the meaning of this minus? Means they have opposite sense, but though they have the same direction, the same line of action, and the same magnitude. And those two vectors, the opposite vectors, they could be parallel, as you can see, or they could be on the same line as this case. The most important one is if I have I, which is the midpoint of the vector AB, then IA plus IB equals to 0. Or IA equals minus IB because they have the same magnitude because I is midpoint, and they have the same direction because they are on the same line of action, but they have opposite sense, one to the right and the other to the left. The new thing that we have learned, the addition of vectors, and in addition of vectors, we have two cases. The first case, which is the chassis relation. If I have vector A, B, so if I went from A to B, then from B to C, it's the same as I started from A and I ended with C. So AB plus BC equals vector AC, as you can see. Okay, so this is the chassis relation. The second thing that we have learned is the parallelogram. Okay, so if I have the vector AB plus vector AD, as you can see here, the two vectors are issued from the same point A, from the same vertex A. So we have vector AB plus vector AD. In this case, we cannot say that AB plus AD equals BD. So AB plus AD equals AC, where C is the fourth vertex that makes a parallelogram. So when you draw this vector, you will get ABCD, a parallelogram. So AB plus AD equals AC, the diagonal, and C is the fourth vertex of the parallelogram. So two cases only for addition of vectors, either the chassis relation or the parallelogram rule. I will talk a little bit about the chassis relation and the difference of between them and the parallelogram rule. If I have AB plus BC, here you can see that the points B and B, you can cross them out and you will get AC. Also, if we have AB plus CA, okay? Also, we have A as the extremities. You can cross them out, but in this case, you flip the vector. It's not BC, it's CB. So either the points should be beside each other, which means end and beginning, or beginning and end. But if in the case of the parallelogram rule, as you can see here, if we have AB plus AC, both of them, they begin the vector with, so both of them are issued from the same vertex. We cannot cross the A's with each other. Of course not. This is cannot be accepted. So what's AB plus AC? You can create any vector, for example, AK, but you have to tell me, for example, that K is the fourth vertex of the parallelogram. Okay, so that's the difference between the chassis relation and the parallelogram rule. Let us continue. Now, how do I decompose a vector? If I have a vector AC, okay, I have a vector AC. I can say that the vector AC is written as AK plus KC. Is this true? Of course, this is true because I can insert any point in the middle, and this is a Chassis relation. So of course I can do it. As you have here AC, you insert the point B. What do you get? AB plus BC. Okay, so you can insert any point. As long as you can cross them out, you can insert any point anytime it's needed. Okay, and there are some properties. They are not actually very important. We solved a lot of exercises. We solved exercise 2. This is exercise 2 that makes everything clear about the vectors. Like, for example, they are asking you a vector AI equals what? K what? It's KC. So this exercise is very important to practice the equal vectors and the opposite vectors. We also solved number 3, which is also very important because in this exercise, you learned how to cross out the vectors. The first step that you have to do to change the minus into plus. Let me solve the first one for you to remember together how do we solve these. So we have BC, you flip the vector BA because it's minus, so you put it plus AB, okay, plus BD, plus, sorry, plus CB. So now I start crossing out. I'm going to choose, for example, the first two vectors. Of course, I can cross them out because the B, it's the beginning and end. Also, I'm going to choose another two vectors, which is BD and CB. Of course, you can cross the B's together. The first two vectors will give me AC. Okay, pay attention. Why AC? Because I crossed out the edges. Also here we will have CD. And now I have AC and CD. I can cross the C's together, so I have one vector AD only. Okay, so that's how I solved number 3. And the most important question that we have solved is, I'm going to solve it again so you remember the important concepts is exercise 11. Okay, in exercise 11 I have 4 points A, B, C, D, any points on the plane such that AI and AJ are given. We have to calculate BI plus BJ. Before I start, okay, I'm going to simplify the vector AI and AJ. So let us solve first AI. Okay, AI equals AC plus AB plus DA. Okay, now what two vectors I can do together? You have many choices. It's either AC and DA or AB and DA. I'm going to choose AB and DA. I will cross out the A's, so the final answer will be AC, AI equals AC plus DB. Okay? I'm done with vector AI. I simplified it as much as I can. Not every time you're going to simplify and get one vector. Pay attention to this very well. So this is the vector AI. Okay? Now I'm going to solve AJ. Okay, AJ equals AB plus CA plus AD. And I'm going to choose the two vectors CA and AD to cross A together. So vector AJ, will be AB plus CD. I'm done with vector AJ. Okay, now I go for what I'm asked for. I'm asked for BI and BJ, but I don't have BI and I don't have BJ. So what I'm going to do is to insert point A. Do you still remember when I said you can enter as whatever you need? So instead of having BI plus BJ, I will insert point A. So I will get BA plus AI, okay, plus BA and AJ, okay? Why did I insert A? Because I have AI and AJ. Now I'm going to replace AI by this value and AJ by this value. So I have It will become bigger, but later on you will see that it will be simplified to the maximum. AI, instead of AI, I'm going to write AC plus DB plus BA. Sorry for the handwriting, okay? But I'm trying as much as I can. No, this is not clear. BA, okay, plus AJ. AJ is AB. Instead of AJ, I'm going to write AB plus CD. Now let us choose some vectors to do together. The first thing is that we have BA and BA, okay? BA and BA. Or in another word, let us take, for example, BA and AC, BA and AC, DB and BA, okay? BA and AC will give me what? BC. And DB plus BA will give me DA. Let us copy the other two. We have AB and CD. I'm going to choose BC with CD and DA with AB. Okay? BC with CD will give me BD, and DA with AB will give me DB. BD and DB, they are two opposite vectors, which means 0. Oh, so BI plus BJ gave me a 0 vector. What does that mean? What can we deduce? We can deduce that B is the midpoint of IJ. Do you still remember when we said that if I have BI plus BJ equals to 0, then B is the midpoint of IJ? So what can we deduce? We can deduce that B is the midpoint of IJ. So that was our lesson. Next week, of course, we're going to start by a new lesson, which is multiplication of vectors.